All right, guys, back at it for week 4. Okay, so this week we're going to be talking about co-functions. I'm sure we'll get some other things in there as well, but we'll start with co-functions today. Okay, so here's what happens in trigonometry. Okay, our trigonometric functions are paired up as pairs of co-functions. Okay, so we have 6 total trigonometric functions, so there's going to be 3 pairs. Okay, and so what happens is if we take a pair of complementary angles from a right triangle, remember in a right triangle these 2 acute angles have to be complementary. And if I take the trig function from a pair of co-functions, if I take one trig function of one angle and the other trig function of the other angle, they'll give me the exact same thing if they're co-functions. Okay, for instance, okay, let's suppose alpha and beta, okay, are these 2 acute angles in a right triangle, so of course we know they're complementary. The sine of alpha would be opposite over hypotenuse, would be x over r, okay, and the cosine of beta would be adjacent over hypotenuse, so it would also be x over r. So since the sine of one acute angle is equal to the cosine of the other acute angle, sine and cosine are co-functions of each other. Okay, tangent and cotangent works. Okay, all right, so let's see. I go the tangent of alpha. Remember, tangent would be opposite over adjacent, so I get x over y. Okay, cotangent would be adjacent over opposite, so the cotangent of b would be x over y. Okay, so the tangent of one acute angle is equal to the cotangent of the other acute angle because these 2 acute angles are complementary, and we get the exact same thing. So tangent and cotangent, okay, are co-functions of each other. Okay, cosecant and secant. Okay, so let's see. If I do cosecant of alpha, well, cosecant is the reciprocal of sine. Okay, so that would be hypotenuse over opposite, so r over x. Secant of b, okay, right here, secant of b, and secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. So again, you're getting r over x. So the cosecant of one acute angle is equal to the secant of the other acute angle because these 2 acute angles are complementary. And so we have pairs of co-functions. Okay, now these co-functions are also on this sheet of paper, okay, right down here. Okay, right down here. Okay, so you have them there as well. So whether you're looking there or you're looking here, okay, it means the same thing. Okay, now usually, okay, just like here, okay, down here, they give them to you. They look a little bit different, okay, than this sheet right here, okay? And I want to show you what's going on down here. And so I've taken those guys and I've blown them up. Okay, so here's what they're saying. Suppose x is some acute angle. Well, then pi over 2 minus x has to be its complement, okay, because pi over 2 minus x, okay, and x, when they're added together, okay, will give you pi over 2, which is the same as 90 degrees. Okay, so these 2 angles, x and pi over 2 minus x, are complements of each other. So since sine and cosine are co-functions, the sine of one has to be equal to the cosine of the other. And it doesn't matter whether you put the x with cosine and the pi over 2 minus x with sine or vice versa. It means the same thing. Okay, same thing here. Again, the x and the pi over 2 minus x are complements of each other. So the tangent of one and the cotangent of the other have to give you the exact same thing. And so we have it in terms of radians up here, and then down here we have it in terms of degrees. Okay, but notice that all of them, okay, it's always going to be 90 minus x or pi over 2 minus x, okay, to get your complement. Okay, so let's see. We can easily illustrate this, okay, with just some random values, okay. Sine and cosine when x equals pi, okay. So let's see, okay. If we say here, okay, obviously we're talking about that top one, and we're going to look at sine and cosine, okay, sine and cosine, okay? So let's see, if we let x equal pi, okay, then pi over 2 minus x would end up being pi over 2 minus pi, so we're going to get negative pi over 2, okay? So these are the two angles we have to work with right there, okay? And so if sine and cosine are co-functions of each other, okay, then the sine of one of those angles, pi, has to be equal to the cosine of the other angle, negative pi over 2, okay? And if I switch the angles, okay, the sine of negative pi over 2 has to be the same as the cosine of pi, okay? And so you can verify that by going right to your unit circle, okay? So let's see what we got, okay? So the sine of pi, remember sine is your y coordinate, so the sine of pi is 0. And the cosine of negative pi over 2, well, we go to negative pi over 2, cosine is your x coordinate, so that's 0. Okay. And then if we do sine of negative pi over 2, coming down here, okay, sine is your y coordinate, that's negative 1. And we go cosine of pi, well, cosine is your x coordinate, that's negative 1. Okay. And notice that again, that even though, you know, you're not talking about two angle measures in a right triangle, because clearly you can't have one of your angle measures and one of your acute angle measures in a right triangle be pi. But notice that pi and negative pi over 2 are a pair of complementary angles, because when you add them together you get pi over 2 or 90 degrees. Okay, so let's see, it wants us to do it with tangent and cotangent. Okay. Bring this guy back down. Okay, so let's go, we're going to go with tangent and cotangent. Okay, and let's see, our x is pi over 4. Okay, so our pi over 2 minus x, okay, gives us pi over 2 minus pi over 4, which gives us pi over 4. So these are the two angle measures that I'm working with. Okay, so we have to show that the tangent, how about tangent, and I write tangent, that makes no sense. Okay, the tangent of one of them, pi over 4, has to be equal to the cotangent of the other one, pi over 4. And then obviously I could switch these two, but it gives me the same thing. So you say, okay, can I verify that? Well, let's go right to our unit circle. Okay, the tangent of pi over 4, okay, would be sine over cosine, so it would be y coordinate over x coordinate, which obviously gives us 1. And the cotangent would be cosine over sine, so it would be the x coordinate over the y coordinate, and again, we get 1. Okay, so that works out. Okay, no big deal. Okay, now it wants us to do secant and cosecant of pi over 6. Okay, so let's see. We got secant and cosecant. And let's see, x is equal to pi over 6. So my pi over 2 minus x would end up being pi over 2 minus pi over 6. Okay, so what's that give us? So let's see. This would be 3 pi over 6 minus pi over 6, so that's 2 pi over 6 or pi over 3. Okay, so we have to be working with this angle here and this angle. Okay, and so I have to show that the secant of one of them, pi over 6, is equal to the cosecant of the other one, pi over 3. Okay, and if I switch the angles, I would get cosecant of pi over 3 equals the secant of, let's see, no, I got the same thing. This would be secant of pi over 3, I'm sorry. It'd be secant of pi over 3. And this would be cosecant of pi over 6. Okay, so again, we go to our unit circle. Okay, let's make sure I got that right. Secant of pi over 6, secant of pi over 3, cosecant of pi over 3. Yeah, okay, we're good. So we bump these guys up so we can take a look. Okay, we go here, and so we say the secant of pi over 6. Okay, so we're right here. Okay, secant is the reciprocal of the cosine, so it'd be the reciprocal of our x-coordinate. So the reciprocal of radical 3 over 2 is 2 over radical 3. And cosecant of pi over 3. Well, we're right up here, pi over 3. Cosecant is the reciprocal of sine, and sine is your y-coordinate. So again, take the reciprocal of radical 3 over 2, and you get 2 over radical 3. Okay, obviously if I rationalize them, I'm going to get the same thing. Okay, then we go here. Secant of pi over 3. Okay, well, secant is the reciprocal of cosine, and cosine is the x-coordinate, so the reciprocal of 1/2 is 2. And then we do cosecant of pi over 6, so we go here. Okay, well, the cosecant is the reciprocal of sine, and sine is your y-coordinate, so we get the reciprocal of 1/2, and that's 2. Okay, so easy stuff, working on the unit circle, not hard at all. Okay, all right, so that stuff's taken care of. No big deal. Let's see. Got that, got that. Okay, these things. Okay, so let's see what's going on here. Okay. All right, so let's see. It says the sine of theta is 0.75. And then you see this theta minus pi over 2. Now, we got a problem there, okay? Because if theta is our angle measure, okay, then its complement would be pi over 2 minus theta, not theta minus pi over 2. Okay, so I have to get this. Let's see, the sine of theta would be equal to the cosine of the complement of theta, which would be pi over 2 minus theta. So I've got to mess around with this guy. Okay, all right, so let's see. How do I get this to be pi over 2 minus theta? How about if I factor out a -1? Okay, so I cosine of, factor out a -1. So theta minus pi over 2 becomes pi over 2 minus theta. Okay, and so that has to be equal to sine of 0.75. Okay. All right, so there we go. Now, this negative right here, okay, that takes us back to our even and odd functions, okay, because we've got to make up our mind, okay, is cosine of the opposite of an angle, is it equal to cosine of that angle, or is cosine of the opposite of some angle equal to the opposite of cosine of the angle? Which one is it? Well, it comes down to whether or not cosine is odd or even. And if we look right here, okay, notice that cosine is even, okay? So that means that this guy on the right is the same as the cosine of pi over 2 minus theta, okay? Okay, so obviously cosine of pi over 2 minus theta is the same as the cosine of theta minus pi over 2 because cosine's an even function. Okay, so that is equal to 0.75. Okay, we're in good shape there. Okay. All right, let's see what's going on here. Okay. Cotangent, cotangent, cotangent. Let's see, what do we have? Cotangent and tangent. Well, we know they're co-functions of each other, okay? So we know the cotangent of theta has to be the same as the tangent of pi over 2 minus theta, okay? And notice that it's pi over 2 minus theta rather than being theta over pi over 2 like up here, okay? So cotangent of theta and tangent of pi over 2 minus theta have to give us the exact same thing because they're co-functions, Okay, so the tangent of pi over 2 minus theta has to be equal to 0.63. Okay. All right, so we come here, cosecant and secant. Okay, and again, notice we're running into the same problem here that we ran into up here. Okay, we need it to be pi over 2 minus theta rather than theta minus pi over 2. So let's see what we can do there. Okay, just like on the one that we did up top with cosine, okay, I've got to take a look at, well, what happens if I go change this from theta minus pi over 2 to pi over 2 minus theta. Okay, so secant, okay, if I factor out a -1, that'll change it to pi over 2 minus theta. Okay, so now it really comes down to right here, is the secant of the opposite of x equal x, or is the secant of the opposite of x equal to -x? Okay, which one is it? Okay, so we go to our even odd, okay, right here, and is secant odd or even? Well, notice secant is even there, okay, which we would expect because it's a reciprocal of cosine, and cosine's even. Okay, so we know that, get rid of that, okay, we know that this guy here is the same as the secant, okay, of pi over 2 minus theta. Okay, well, by definition, with our odd and even functions, okay, right here, okay, look here, cosecant of a number is the same as secant of the complement of that number. Okay, so that means that this guy right here has to be the same as the cosecant of theta. Okay, so if the secant of theta minus pi over 2 is the same as the secant of pi over 2 minus theta, okay, this guy has to be equal to the cosecant of theta, or 7/2. Okay, then we're in good shape. It's easy stuff. Okay, just coming back to this, you know, and obviously depending on whether we have, you know, theta minus pi over 2 or pi over 2 minus theta, okay, you've got to use your odd and even identities, okay? And remember, those odd and even identities are also on here somewhere, right here, okay? So we've got them in multiple places, okay? So that's some relatively easy stuff, okay? And we'll call it, wrap it up for today. Don't forget about your quizzes are due tonight, and I will have the quiz for this week, which will be due next week. All of that stuff posted probably on Wednesday. You guys make sure you're safe out there, and I miss you a whole bunch.